All right, we're going to look at horizontal asymptotes now and look at three different examples. And we'll notice that there are three different possibilities in comparing the degree of the numerator and denominator. Either the degree of the numerator, n in this case, if you're looking at this theorem here, either the degree of the numerator is smaller, less than the degree of the denominator. Notice that if you look up here at the function, the n right here, this n value, is going to be smaller than m. So the degree of the numerator is smaller than the degree of the denominator. And in this case, then the x-axis, which is the line given by y equals 0, we'll see what what we mean by this, is the horizontal asymptote of the graph of f. So we'll check this out. And then also, if n is equal to m, meaning the degree of the numerator is equal to the degree of the denominator, then the line a sub n, meaning the coefficient of the numerator, of the leading term of the numerator, is divided by the leading coefficient of the degree of the denominator, is the horizontal asymptote of the graph of f. So we'll look at that ratio, an divided by bm. So if n is greater than m, so either n is less, n is equal, or n is greater than m, then the graph of s has no horizontal asymptote. So we may have no horizontal asymptote. We may actually have y equals 0 be our horizontal asymptote, or we're going to be looking at the ratio of the leading coefficients. So we'll see how this works out in three different examples. So looking at A, we have the, I'll just rewrite this a little bit bigger so we can see what's going on. Okay, so now all we really want to do at first is compare n and m and see which one is larger. So notice that that n and m, again, underlining this, n and m are the exponents of the leading coefficients of the numerator and denominator. So notice that for the numerator, the degree of the numerator is 1. It's not written there, but you should know that it has an exponent of 1. And we're comparing this to the degree, and I'll write this in blue. We're comparing 1 to 2. And keep in mind that the degree of the numerator in this theorem is n, and the denominator is m. So in this case, n is equal to 1, and m is equal to 2. So if we're doing this comparison here, we're looking at this table, or this theorem, we have n is less than m, because 1 is less than 2. So we're looking at criteria 1. So what we notice is if the degree on the top is less than the degree in the denominator, then we have this first criteria. So what we end up having is a horizontal asymptote at y equals 0. So that tells us y equals 0 is a horizontal asymptote. Okay, so what this would look like is, if we're going to graph this, and you may want to look at the first video to really to see this broken down. If we have y equals 0 is a horizontal asymptote, then that tells us that the function of this will, now we would need more details to be able to graph this, but we know that it would approach this horizontal line at the x-axis. So it might look like this, and maybe something like this. So it would approach the line y equals 0 as x goes towards negative infinity or positive infinity. So keep that in mind. We would have the following graph in general. We don't know exactly if it's coming up from above or below, but we know that it's approaching y equals 0, and that is known as our horizontal asymptote. Okay, so that's the case when n is less than m. We have this horizontal asymptote. Now let's go ahead and look at the next example. We'll use a different color here. And we have g of x, so this is part, oh, this is part B. So g of x, oh wow, really butchering this. We have g of x equals 4x squared plus 1 over 3x squared. All right, once again, all we really care about is the leading exponent. So as we can see, we have the same leading exponent. So since we have the same leading exponent, then that means n is equal to m. N is equal to m, so that tells us we need to look at the ratios of the leading terms. So the horizontal asymptote would be a sub n over b sub m. So that would be 4 over 3, looking at these two coefficients. So 4 over 3 is our horizontal asymptote. This is our horizontal asymptote. Okay, so we have our horizontal asymptote. Since the exponents for the leading terms are equal, so we just look at the ratio. Okay, so we have our horizontal asymptote for the case n equals m. Now let's look at another example. For C, we have h of x equals x cubed plus 1 over x minus 2. All right, so we notice that x minus 2, the exponent here for x is just 1. So notice that in this case, again, n is the numerator exponent, so n is equal to 3, and m is equal to 1. So in this case, n is greater than m, since the degree on the numerator is larger than the degree on the denominator. So n is greater than m, so that tells us that well, we're in this case here, n is greater than m, then f has no horizontal asymptote. So we have no horizontal asymptote. So something to keep in mind I really want to point out. So no horizontal asymptote. So what I really want to point out right now is that we only care about the leading terms. So notice that we just ignored, you know, the plus 3, the plus 1. We ignored the plus 1 here. We ignored plus 1 here and the minus 2 right there. So we just look at the leading terms. It just comes down to the exponents of the leading terms to determine our horizontal asymptote. So do keep in mind that if your function is not in standard form, if the numerator and denominator is not in descending order of powers, you must make sure that you're looking at the leading term. So it might help to put your numerator and denominator in descending order of powers so that your leading term is up in front. So do keep that in mind when you look at a problem you're working on. And then it comes down to these three criteria. Is n less than m? Is n equal to m? Is n greater than m? Then we have the following three results. Either y equals 0, or the ratio of the leading coefficients, or there's no horizontal asymptote. So hopefully that makes sense. And just really quickly, you know, I would encourage you to try to graph what the horizontal asymptote will look like here. I'll go ahead and do that down here. So notice that at like 4/3, which is just above 1, we would have a horizontal asymptote. So in this case, our function would be maybe approaching y equals 4/3. but never touching y equals 4/3 as it approaches negative infinity and positive infinity for x. So let me know if you have any concerns about this. Hopefully you can make the connections with horizontal and vertical asymptotes, what we've discussed in the last 2 slides, compared to the graphs from the first slide. And if you have any concerns, let me know. I'll be more than happy to help. Next, we're going to be looking at slant asymptotes. And yeah, so let me know if you have any concerns.